Hey everybody! So really quickly, this video is going to be over the structure of the retina. So hopefully by now you've gone over the entire structure of the eye. So you know that the eye has that clear transparent dome at the front called your cornea. Behind it is your iris, which is a muscle that opens and closes, which increases or decreases the size of your pupil. And behind the pupil is a clear transparent sac of fluid called the lens. And the cornea and the lens focus the light on the back of your eye, the area where all your receptor cells are, called the retina. Now it's at the retina, in the receptor cells, that transduction happens. Transduction is when an energy, like light, is turned into an electrical signal that your brain can interpret. Okay, so the retina in the back of your eye looks roughly like this. Okay, you have a small area in the center that we call the fovea, and you have a larger surrounding area called the peripheral fovea. Now, the reason we differentiate between the fovea and the perifovea is because there are different distributions of the receptor cells in the two areas. In general, there are two kinds of receptor cells. You have the cones, which are sensitive to color and detail, and you have the rods, which are sensitive to brightness and basic shapes and form. This is a chart that kind of shows you the distribution of the cones and rods across the eye. So if you look right there, you'll see here's your cornea right there. Here's the back of your eye. So 0 degrees is right behind the pupil. All right, it's when you're looking straight at something that's where the light's going to be focused. And as you move away from the center, you get a higher degree distance from the center. So if we go back and we look up at this one, okay, the solid line is the distribution of rods, and the dotted line is the distribution of cones. So what you can see is that the cones, so here's 0 degrees, here's 80 degrees out here and over here. You can see that the cones are far more densely packed at 0 degrees, so right behind the front of the eye, and then they fan out. They're still present throughout the eye, but they're not as densely packed. Whereas rods do kind of the opposite. There's almost none at the direct center of the eye, but then they increase dramatically in density as you move slightly away from center, and then they trail off. But they're in the peripheral areas of the retina. They are always higher density. There's always a higher number of rods than there are cones. Now you might be wondering what this black bar is. That black bar represents your blind spot. There is a hole in the back of your eye that your ganglion cells send signals out through. Because that is a hole in the back of your eye, you don't have receptor cells there, so you can't see anything there. That's what that black bar is. So there are no cones, there are no rods in your blind spot. Now, let's talk about the retina, because it's organized in a way that would seem a little backwards. So here's a chart that plots a rough layout of how cells are organized. So one thing I want to draw your attention to is that if you look at the top of the page, it says back of the eye, but all the receptors are pointed to it. Now that seems backwards, but it's not. So what happens is that your ganglions, so you have multiple kinds of cells in your retina. You can see here you have receptor cells, your rods and cones. Below those you have bipolar cells, and below those you have ganglion cells. And ganglion cells are the cells that actually carry the signal onto your brain. Now in between here you have horizontal cells, and between the bipolar and ganglion cells you have cells that are called amacrine cells. Now horizontal cells and amacrine cells seem to be specialized for lateral transmission. That means they send signals between cells on the same layer. Okay, so the horizontal cells send signals between receptors and between bipolar cells. Amacrine cells send signals between ganglion cells. Okay? Now, back to the seemingly backwards organization of your eye. So ganglion cells, bipolar cells, receptor cells, horizontal cells, amacrine cells, they're all transparent. So they are all pointed towards, so if this is the back of your eye, light's coming in over here, your receptor cells are pointed this way. They're pointed towards the back. So the light has to go in through the eye, pass through your ganglion cells, your bipolar cells, and your receptor cells in order to get to the tips of your receptor cells. So in order for light to get in, it has to go through your ganglion cells, your bipolar cells, horizontal, amacrine, and receptor cells. Now, there's a reason that your receptor cells are attached to the back of your eye. Specifically, that allows them to be close to the pigment epithelium. Now, the pigment epithelium releases an enzyme that basically regenerates your receptor cells. It allows them to keep seeing. If your receptor cells ever get detached from the back of your eye, you have what's called a detached retina. And your retinas, after they see light once, they can't see again because the pigment epithelium can't release the enzyme that regenerates them. So, it seems backwards, but here are your receptor cells, and light comes in this way. This is the back of your eye. Your pigment epithelium that regenerates your receptor cells is back here. Okay? Now, that's the structure of your retina. I tried to keep it quick. It got up to almost 7 minutes. Sorry about that. I hope you didn't get too bored. I hope it didn't go too fast that I lost any of you. Let me know if you have any questions.